Great people, welcome to NameTech channel. My name is Nehemiah and I'm so happy to have you on board. This is lesson 9 on Scipy, and we are going to talk about Scipy statistical significance test. But then guys, before we begin, please take a minute, subscribe, like and share the video to your friends. And to the returning subscribers, thank you very much for your continuous support. First of all, what is statistical significance test? In statistics, statistical significance means that the result that was produced has a reason behind it. It was not produced randomly or by chance. Now, Scipy provides us with a module called scipy.stats, which has the function for performing statistical significance tests. Here are some of the techniques and the keywords that are important when performing such tests. And the first one is hypothesis in statistics. Now, the term hypothesis is an assumption about a parameter in a population. The first category in this hypothesis is the null hypothesis. This one assumes that the observation is not statistically significant. And the second one is alternate hypothesis. And then this one assumes that the observation are due to some reason. It is alternate to the null hypothesis. Now, the other category is one-tailed test. Now, when our hypothesis is testing for one side of the value only, it is called one-tailed test. Now for two-tailed testing for both sides of the values. Then alpha value, basically this one is the level of significance, and then the p-value, guys, basically this one tells us how close to the extreme the data actually is. Now, p-value and the alpha value are compared to establish statistical significance. Now, if a p-value is less than or equal to alpha, we reject the null hypothesis and say that the data is statistically significant. Otherwise, we accept the null hypothesis. Now, let me talk about the t-test in a few. T-tests are used to determine if there is a significant difference between means of two variables and let us know if they belong to the same distribution. It is a two-tailed test. Now, the function t-test underscore I and D function takes two samples of the same size and produces a tuple of t statistics and a p-value. So guys, let me show you an example here to find if the values, perhaps v1 and v2, are from the same distribution. What I do in this text editor, let me import the module. First of all, we are going to import the numpy as what np alias, also from Scipy. So let me say from scipy.stats for statistics dot stats import t-test underscore I and D. Then again, here I'm gonna create two values. Now here, let me give it perhaps value 1, then assign it to, basically np dot random. So it will just produce a random value. So let me say dot random between the range of let me first of all give it normal, and then the range should be between basically, let me say the size should be perhaps 100. What I do is, let me just duplicate this code. Let me copy, though it's not a good practice, but then let me paste it here, and then here let me change it to v2, and then what I do here, let me say what, let me create a variable here for our result. Then let me assign it to t-test underscore I and D, and then let's pass in v1, should be v1 and v2, and then let me print out what, let me say, sorry, let me say print what we're gonna print res. And then what I do, let me run these codes at the terminal. So guys, basically this is how you can find if the given values v1 and these are v2 are from the same distribution. And remember guys, I said that the p values you can see here, at the end, at the results, basically the p value tells us how close to the extreme the data actually is, and the p value and the alpha values are compared to establish statistical significance. And guys, if these are p value is less than or equal to alpha, we reject the null hypothesis and say that the data is statistically significant. Otherwise we accept the null hypothesis. So guys, basically when doing these t-tests, I say that t-tests are used to determine if there is a significant difference between means of these two variables, and let us know if they belong to the same distribution, and it is a two-tailed test. And this function t-test, these are function t-test takes these are two samples and produces the tuples of the statistics t statistics and the p value. Now guys, basically if you want to return perhaps the p value only, we are going to add that property, p value property here, dot p value, then let me guys run, and then guys, basically that's how you can just produce what the p value property. So guys, let me now talk about the KS test. The KS test is used to check if given values follow a distribution, and the function takes the values to be tested, and the CDF has two parameters. Talking about CDF, basically a CDF can either be a string or a callable function that returns the probability. And guys, basically it can be used as one-tailed or a two-tailed test. By default is a two-tailed, but we can pass a parameter or alternative as a string of one of the two sides, less or a greater. Now guys, let me show you an example here how to find if the given values follow the normal distribution or not. So what I do guys, here let me change the module to KS test, and then here guys, perhaps let me just use this first variable, and then let me delete the second one, and then here the terminal, let me now change it to KS test function, KS test function. Then here guys, I'm gonna pass in that variable, and then also we're gonna add this argument here, norm, this parameter here. Then let me remove this property here at the end, and then again, what I do, let me run these codes at the terminal, and then again, basically this is how you can find if the given values follow the normal distribution. So guys, let me now talk about statistical description of data. Now in order to see a summary of values in an array, we can use the describe function, and it returns the following description. The first one is the number of observation, that is NOPs, number of observation. The second one is minimum and the maximum values, that is min max. And then the third one is mean, and then the fourth one is variance, then the fifth one is skewness, and then the sixth one is the kurtosis. Now guys, let me show you an example how to show a statistical description of values in an array. So in that case guys, we are going to use the function describe. Let me change the module to describe. This should be describe, right? Describe like this, and then here let me change here the the function to describe. Let me change it to describe. So guys, basically I want to show this codes to show statistical description of values in an array. So what I'm gonna do guys, here let me run the codes. Let me run the codes, and then guys, basically you can see it describe the results here as the as the number of observation. The first description, the second description is min max. This one is basically the minimum and the maximum values, and then you can see the minimum is negative whatever, and then at the maximum, and then at the mean it shows the mean, also it shows the variance, it shows the skewness, and also it shows the kurtosis. So guys, let me talk about normality test, that is skewness or and kurtosis. Now basically guys, the normality tests are based on the skewness and the kurtosis. The normal test function returns the p-value of the for the null hypothesis. Remember, x comes from a normal distribution. Now guys, let me talk about this skewness in a few. Basically is a measure of symmetry in the data. For normal distribution it is 0. Now if it's negative, it means that the data skewed is left, and then if it's positive, it means that the data is skewed right. And for kurtosis, it's a measure of whether the data is heavy or lightly tailed to a normal distribution. Positive kurtosis means it is heavily tailed. Negative kurtosis means lightly tailed. Now guys, let me show you how to find skewness and the kurtosis of values in an array. In that case guys, we are going to change the modules here to skew, and what in the kurtosis, and then here guys, we are gonna print out basically we are gonna print two values here. So the first one, let me say print is gonna print the skew. I want us to print the skew of values of v, and then the second one I want it to print that the kurtosis of the same variable v. And then what I do, let me run these codes at the terminal, and then guys, basically you can see this one is the values of the of the skew, and then the second one is the value from the kurtosis. Guys, basically this is how you can find the skewness in the kurtosis. And I say that the positive kurtosis in this second one, if it were positive, it means it is heavily tailed, but then as you can see it is negative, which means it is lightly tailed. And then for the skew, actually for negative, it means that the data is skewed left, and then if it is positive like this one, it means that the data is skewed right. So guys, basically that's how you can do it. That's how you can find skewness in the kurtosis of in an array. Let me show you guys another example here to find if the data comes from a normal distribution. Now in that case guys, what I do here, the print function, I'm gonna just change it to what normal test. Sorry, instead of skew, I'm gonna change it to what normal test. And then guys, the other thing, you must not forget to add the module here at the top, otherwise you'll have an error at the terminal. And then here it should be normal test, normal test, like that. Then let's run our codes, and then guys, basically that's how you can obtain the normal test results. And so guys, basically this is all about Scipy statistical significance test that I wanted to show you in this video, and I guess you've gained something. Now guys, consider subscribing, like, and share the video to your friends. Until next time, this is Nehemiah. Goodbye.